my dear students of class 9 and 10 English version. This is Russell sir in physics class. Today our topic is waves and sound. Basically today we'll discuss regarding waves. So first of all, let us know what we mean by waves. Waves means a process or a phenomenon by which energy can transfer from one place to another place through a medium without permanently changing the position of the particle of the medium. So wave means a process. Wave is the process by which energy can travel or transfer from one place to another place through a medium without changing the position of the particle of the medium permanently. Here actually basically the waves are two types, mechanical waves and electromagnetic waves. Mechanical waves. Mechanical waves, what is the mechanical waves? Mechanical waves is a kind of waves which requires medium to travel from one place to another place. I mean, without medium, mechanical waves cannot travel. It means it requires any one of the medium, like gaseous medium, liquid medium, or solid medium. Now, let us know the types of mechanical waves. There are two types of mechanical waves, longitudinal waves and transverse wave. You see here, I have drawn a figure for you. You see, it actually looks like a slinky toy or a spring. You see, here, if you compress it and expand it, you see, then energy will transfer from one end to another end. But the particle, I mean the medium, the spring, won't change their position permanently. So the longitudinal waves, where the direction of the displacement of medium is the same, the propagation of the wave. So longitudinal waves, where the direction of the displacement of the medium and the direction of the wave is in the same direction. Suppose if you hang a spring with a hook and if you tie a weight with the other end of the spring and if you release it, then it will go up and down. It will oscillate. It will oscillate. And you see, during the oscillation, the spring will compress and expand. Compress and expand. But the position of the spring or the two ends of the spring won't change permanently. Just the energy is transferring through the oscillation. So this is the longitudinal wave. The sound wave is a very good example of longitudinal wave. We'll discuss it when we'll discuss about the sound in next class, inshallah. Now come to the transverse wave. Transverse wave is it. The direction of the displacement of the medium in the propagation of the wave is perpendicular to each other. You see here. This is the displacement of the wave. Displacement of the medium. Suppose it's a rope. Suppose it's a rope. Okay. Now, if you tie one end of the rope with anything or any hook and by catching the other end of the rope, if you oscillate it, then it will get the shape of like this And you see that you are applying force here, energy is transferring through the rope to other end. Here you see the rope is oscillating ups and down, and the energy is going straight horizontally. So here the direction of the displacement of the medium and the propagation of the wave is perpendicular to each other. So such type of waves are called the transverse wave. You see here the maximum displacement of the medium or the particle of the medium is called the amplitude, and highest peak is called the crest. Okay, and the distance covered by the two crests is called the wavelength. It's called the wavelength, and the number of total completed vibration in a second is called the frequency. Frequency, the total number of completed vibration or oscillation in a second is called the frequency. Velocity, you know, the velocity of the wave, it differs medium to medium. Suppose sound wave, least in gaseous medium and highest in solid medium. Later we'll discuss it. Time, T for time, I mean period. The taking time to complete one oscillation. Lambda, wavelength. Lambda denotes the wavelength. Wavelength, I said to you, the distance covered by two crests is wavelength. So here the relation in between the terms are given here. I mean frequency, velocity, time period and wavelength, how are they related each other? Here it is shown here. You see frequency inversely related to the time period. Frequency inversely related to the time period. That's why F is equal to 1 by T. And rearranging equation, T equal to 1 by F. And velocity of the wave, if you want to get the velocity of the wave, then easily you can get by this equation V equal to F lambda. The times of frequency and wavelength denotes the velocity. Rearranging this equation, you can get the frequency, you can find out the wavelength also. So here three terms are very closely related to each other. So any two of them, if you know, easily you can get the rest one. Later, in next class, I will show you how to solve the numerical problems, I mean mathematical problems on the topic using this equation. We'll show you, and we'll discuss about the sound wave also. So bye for today.